Okay, guys, welcome to the test 4.4 reteach. So I'm going to go through a version of test 4.4, and you guys can review it and make sure that you complete the reflection questions on each question and on the end of the packet in order to be able to reassess this test. Okay, so starting with question one. Question one says if f of x has an inverse and f of a equals b, then f inverse of b equals a. Well, very simply, what are they saying here? They're saying that you have a point A, B, right? That's x and y is a comma b in the function f of x, right? And on your inverse, remember those two should switch, right? And that's all there is to it, right? Your x and y switch for the inverse. So this is definitely true, okay? And it's just that the x and y from a function to the inverse are switched. All right, number two says, which is the inverse of the function below? So we're actually going to take this and find the inverse, okay? So we're going to start by switching our x and y values, right? So we're going to now have x equals the cube root, right? Remember that 3, negative y plus 2 over 2. And we can just go ahead and start solving this. So we're going to start by cubing each side. And so now we've got x cubed equals negative y plus 2 over 2. Next step, we're going to keep working our way to getting this y by itself. So we're going to multiply by 2 on each side, and now we've got 2x cubed on the left, negative y plus 2. These have canceled out. And if we keep following this through, we're going to say, hey, next thing, let's subtract 2. Okay, and by subtracting 2 here, we're going to have now that y is by itself, negative y. And of course, we don't want to leave it as negative y, we want positive y. Divide by negative 1, and we've got negative 2x cubed plus 2 is the y, which is f inverse of x. Okay, so once I've got that y by itself, I know I have the inverse. So we're going to look for that answer choice. And you can see that it's actually this first one. They just have the order flipped. Okay, so this is the same as this one. Okay, and it's just got that order flipped around. Okay, so as we look at question 3, we're looking for what f minus g of negative 1 is. Okay, so we can just set up f minus g first, right? So we're going to set up f of x minus g of x. And let's just see what we get first. So we've got x squared plus 4. That's my f of x portion. Minus g was 3x minus 1. So let's simplify this. Remember, this negative sign, key thing, these parentheses, this negative sign is going to influence both of these. So we're going to have minus 3x and plus 1. So here we go. I've got x squared minus 3x, and this 4 and the 1 will combine to make plus 5. Okay, and I want to plug in negative 1 in there. So now we can plug negative 1 in here. So we got negative 1 squared minus 3 times negative 1 plus 5. If we compute this out, 1 plus 3 plus 5 is going to give me 9. And that should have been my final answer. So I went ahead and started by subtracting the 2, right? F of x minus g of x. Combined my like terms and then plugged in my negative 1 at the end. Now we could have plugged in negative 1 at any step in this process and gotten the answer, but I just waited until the end. Okay, so we've got another function combination here. This time we've got f plus g. So here we go. Here's f of x plus g of x. All right, and we're gonna just go write these out. So here's f. We got 3x minus 5 And g is going to be x squared minus 2. Okay, parentheses, let's just make sure we don't miss any signs or anything like that. And now we can combine our like terms. So I see x squared plus 3x, right? Those guys don't have any combinations. Minus 5 and minus 2 will make minus 7, right? And again, I have a number that I'm actually looking for here. I'm going to look for this 8. So let's plug 8 in here and see what we've got. So 8 squared plus 3 times 8 minus 7, 64 plus 24 minus 7. So we get 88 minus 7 is 81. Okay, and that's my final answer for this. Okay, this was another numeric response, so you should have just had a number as your answer. Okay, so question 5 is asking us to verify if these are inverses, and there are two real good approaches to this. Okay, one of them is to check if f of g of x and g of f of x are both equal to x. Okay, so those should both be equal, and they should both come out to be x. Now, if either of those is not the case, then we immediately know that these are not inverses. Okay, the other option we would have here is to actually find the inverse of one of these and see if those inverses actually match up. So we're going to do a little bit of both. We're going to do one of each, okay, just so that we can see it. So I'm going to start with this one right here, f of g of x, and we're going to see if we can get to just x from there. Okay, so f reads as being 4 over negative x, and I'm using this blank for a second as my x because I'm going to plug in that g in there. And my g, this piece right here, is going to read as negative 4 over x plus 1 plus 2. And it's a little crammed in there, but things are going to start simplifying once we can combine a few of these things. The first thing that jumped out to me here was the negative sign at the bottom, right there and right there. So those two negatives have got to do something when I put them together. So I'm going to combine this by distributing my negative sign in, and that 2 is going to be a minus 2 now. So here's what I've got. 4 over x plus 1 minus 2 plus 2, and with that minus 1 tacked on at the end. Now, the next thing that I see that's going to cancel out are these plus 2 and minus 2's. And now from here, we're going to be able to simplify our fraction down even further. We've got 4 over x plus 1 minus 1. And some of you guys may already recognize what's going on with this fraction, right? We're going to flip this and multiply it to the top. So we've got 4 times x plus 1 over 4 minus 1. And these are, again, going to cancel out as well. My 4's will cancel out. X plus 1 minus 1 is going to give me x. Okay, and so that's proving it f of g of x, and we could repeat this whole process again for g of f of x, and we should end up in the same place. Okay, now this approach may seem a little bit messy, right? Especially as we get through this fraction, so we can look a little bit closer here, and you can see there are quite a few steps to this. But what if I said, instead of doing this, I'm going to find the inverse of one of these functions? And that may have actually been easier in this case. So over here, I'm going to go ahead and try to find the inverse of f of x and see if it's the same as g of x, right? So the first step for finding the inverse, we're going to switch our x's and y's. So we're looking for f inverse of x, okay? And we've got this right now. X equals 4 over negative y plus 2 minus 1. And let's just start moving stuff over until we've got that y by itself. So I'm going to start with the plus 1. X plus 1 equals 4 over negative y plus 2. And we can multiply our denominator to the other side. So negative y plus 2. So on this side is going to cancel out. On this side, I've got negative y plus 2 times x plus 1. And I'm not going to distribute. We don't want to mix these together yet. Okay, so here we go, equals 4. Let's go ahead and start moving the pieces that don't have y over. So here, let's move that x plus 1, x plus 1. Get rid of those. Negative y plus 2 equals 4 over x plus 1. Subtract the 2, minus 2. And let's take that negative to the other side. And here we are. Y equals negative 4 over x plus 1 plus 2. And we're going to see, hey, look, that is the same as this. So we can again put our little check mark and say, hey, yes, f inverse of x is the same as g of x. And we've kind of proven that they're inverses that way. So of course, with both of these methods, we would want to go through and say, hey, you know, we have to show it both ways, that f of g of x and g of f of x equal x, or that we can find the inverse both ways and solve it out. Now, I think finding the inverse method, the second way I showed you, is a little bit easier. It requires a little bit less work on the fractions. I think the one step where people will mess this up is sometimes over here, when we multiply that y minus 2, people instinctively want to distribute it. Okay, but if you distribute it, you've now made your function even messier, and you won't get an answer that looks like g of x. Even though you'll have that inverse, it will look a little bit different than what you expect it to. Okay, so here's another example of that question 5, a little bit of an easier example, something you might have seen on the academic test. Okay, so again, remember, to prove or verify that these are inverses, we can use the f of g of x, and we know that we should get just a plain old x back from that. Okay, so let's see if everything kind of cancels out when we set this up. So here's f of x, the fifth root of minus 1 plus 2. And inside of my parentheses, I'm going to plug in g of x, which is parentheses x minus 2 to the fifth minus 2. And really quickly, I'm just going to see that this minus 2 and this plus 1, this minus 1 that were supposed to be the first thing to cancel out are not canceling out. And that immediately is going to tell me that these are not inverses, okay? Because my end result is something other than x. I don't get to x. So we're kind of stuck, and we're going to say, hey, yeah, these are not inverses. Okay, now what if we tried the other method where we actually found the inverse? Okay, so let's find f inverse based on this. So here we go. We've got that's switched x and y. So x equals the fifth root of y minus 1 plus 2 outside. So let's get that y by itself. I'm going to start by moving this 2 over. Subtract 2. We got x minus 2 is the fifth root of y minus 1. Let's raise these both to 5. Okay, so this might be something you've forgotten, but we use that fifth power to cancel out the fifth root. X minus 2 equals y minus 1. Again, we see that fifth power. Okay, and we're going to add 1 to both sides. So here's my final result. X minus 2 to the fifth plus 1 is y. And this is not the same as g of x, okay? So even though it looks kind of similar, I'm only off by one number, but this is not the same as g of x. Which means these are, again, not inverses. That's basically what we learned. So either way you did it, whether you tried to cancel it out and found that they were not inverses, or whether you simplified it and tried to find the inverse, you would discover that they are not inverses because they are different numbers. Okay, question 6, a little bit of a break from all that algebra. We're trying to determine if these two graphs are inverses of one another, right? So we might call this one f of x and this one g of x. Can you tell me if these are inverses? Well, remember, inverses have switched x and y's. And the first obvious point I see is right here. and that's 0, 4, and that's on my green line, g of x. Okay, so if I have 0, comma 4, my inverse function should have 4, comma 0 right here. And you can see this point is not on f of x, right? So this original point is on g of x, but this one is not on f of x, which means these are not having those switched x and y's, so these are not inverses. Okay, so as soon as we found a point that didn't match up, we could also have looked at our y equals x line. It's a little trickier to see it on this graph, but we can see that this line does not have that reflection that we're looking for. Okay, so immediately we can discover, hey, these are not inverses. Again, look for the switched x, y. If they don't match up, you immediately know these are not inverses. Okay, we've got another problem where they've given us f of x and g of x, and they want us to find f of g of -2. Okay, so let's set this up first. Again, I'm going to start by doing f of g of x, and then we'll plug in -2 at the very end. So here we go. I've got -2 minus blank. And each of those blanks was an x initially. And what I'm going to do is I'm going to plug in what g of x was into there. So here we go. I've got 4x plus 5 squared and minus, again, 4x plus 5. Now, I'm not going to actually simplify this because I could FOIL this whole thing out and kind of work it down. But in this case, it's easier if I just plug in my number and kind of work this out numerically. So here we go, 4 times 2 plus 5. All right, and let's see what we've got. So here I've got 4 times 2 is 8, plus 5 is 13. So -2 times 13 squared minus, this is going to be an 8, plus 5 is another 13, right? And here we go. So we've got -2 times 169 minus 13. And we should get this as -338 minus 13, or -351. Okay. And you can see I kind of saved myself a little bit of algebra by plugging in my number at that step. Okay. We could have also gone through and plugged in -2 into g, found that value, and then plugged that into my f of x. So we could have done it with that two-step method as well. But I like setting it up and then plugging in the number and seeing where we end up. Okay, if f of x is these points, is the inverse of that function a function, right? So we're looking for that horizontal line test. And we could kind of plot these points if we really wanted to see, but we could also just look at the inverse of these and say, wait a minute, look, here's 7, 3, 2, 4, 1, 5, 7, 6. And we immediately kind of see, look, this repeated y value becomes a repeated x value. And that's kind of bad news for us. So I'm going to go ahead and say this is not going to have an inverse that's a function. It would fail this because it's got duplicate y's. Okay, so if this is f of x, this would have been f inverse. And you can see that doesn't pass the vertical line test. Your original function didn't pass that horizontal line test. Okay. All right, question 9. We've got a division problem using function composition. So here we go. Let's combine these together first. So h divided by g, we've got -x cubed plus 3x over 3x minus 4. And we want this of 5, so we're just going to plug 5 in for our numbers here. Let's see what we've got. We've got -5 cubed plus 3 times 5 over 3 times 5 minus 4. Okay, and simplifying, negative 125 plus 15 over 15 minus 4. And so we've got negative 110 over 11, which should just give us negative 10 as our final answer. Okay. What's the inverse of the given coordinates? Remember, guys, this one should be second nature. We're just switching the x and y values. So this is 3, 2, 6, negative 3, and 4, 7. Okay, x and y switch. No changes in those signs. Okay, so here you go. 3, 2, 6, negative 3, and 4, 7. All right, last one, we've got a composition, but this time, watch out, they wanted us to plug in x minus 2. So let's start by doing f of g of x again, and then we'll put in that x minus 2 in our next spot, okay? So f of g, negative 2, and we've got plus 1, and inside my g of x is going to be x squared minus 3x, okay? And let's go ahead and distribute this in here, negative 2x squared plus 6x plus 1. That 1 did not get distributed to, guys. Watch out for that. Okay. And now I've got f of g of x. We're going to replace our x's with these x minus 2's. So here's what we've got. Negative 2 x minus 2 plus 6 x minus 2 plus 1. Right? And this is f of g of x minus 2. Now you may look at this and tell me, wait a minute, this does not look like any of my answers. And that's because it's not simplified all the way down. Okay, so we're gonna need to make sure that we simplify this in order to get our final answer. And it could get a little messy, but it should all simplify and combine nicely. So first we will use FOIL for this, okay? Don't ever forget that. Negative 2 x squared minus 4x plus 2 plus 4, sorry. Plus, I'm going to distribute my 6 in here. 6x minus 12 plus 1. Okay, distribute our negative 2 in here. And we got negative 2x squared plus 8x minus 8 plus 6x minus 12 plus 1. All right, now that we've got everything distributed and simplified nicely, let's combine our three real numbers, okay? And my two x's can combine, so negative 2x squared stands alone by itself. My two x's are going to be 14x. Negative 8 and negative 12 make negative 20, plus 1 is minus 19. And let's look for that answer choice. Here we go. That very first one was my answer. Okay, so this is f of g of x minus 2. So after you've plugged it in, you just got to make sure that you distribute and FOIL. Once you combine those like terms, you should get one of your answer choices. Okay. Now, some of these are definitely a higher level than what we did in the academic test, guys. So try to take these concepts in, how we plugged stuff in and canceled to verify inverses, how we plugged in functions into one another. Okay. All right. I hope this video was helpful and informative. Good luck on all of your reassessments.